Okay, let's do on page 504, problem number 41. I'm recording this on May 2nd, 2014 in fourth period physics. Woo! Everybody say hello. Say hello. Yeah, you're immortalized now. Yeah. Oh gosh, gotta come over here. Yes. Yeah, where are you? Oh, there they are. Wow, okay. All right, so that was, maybe I should edit that out. I hope none of you are in the witness protection program because now you're going to be on YouTube. All right, so anyway, this is the problem. Let me read it. Shush thyself. What is the charge in a 15 picofarad capacitor when it is connected across a 75 volt source? Now, a source is a battery. You know, you've got something that's pushing the electrons onto, or pushing, well, actually it does push electrons, but we pretend like it pushes positive charge, and we want to know how much charge there is. So what a battery actually does is it shoves electrons along, and so you're going to get a whole bunch of electrons over here. Now, we pretend like it's pushing positive charge onto the other plate, and it works just as well in terms of problem solving. And so we get an electric field from the positive to the negative inside that capacitor. Now, between the plates, what is between the plates of a capacitor? It could be glass, it could be a putty of some kind, or even paper. Sometimes they use wax paper. It is something that will not conduct electricity. It's an insulator in between the plates of a capacitor. But this is the symbol for it. It's just two plates like this, and that are parallel to each other, and you can put charge on one plate and the opposite charge on the other plate. And the amount of charge you get depends on the capacitor itself and how much voltage you put across it. So the basic equation for a capacitor is the capacitance of a capacitor is, by definition, the charge you get on the positive plate divided by the potential difference that you put across those plates, delta V. This is coulombs per volt. And what is a coulomb per volt? A farad. That's what a farad is. So in this problem, we're given the capacitance and we're given the voltage. We want to find the charge. So it's a pretty simple problem. Now, hey, you guys, be careful. I actually had people improperly solve for the charge. They got the wrong equation. Okay, so, I mean, they started with this and then they solved for it. So just be careful. Multiply both sides by voltage. When you do, that cancels out on this side, and you get the charge is equal to the capacitance times the potential difference across the plates. Then you had to know what pico meant. 15 times 10 to the negative 12. And then what are the units for capacitance? Coulombs per volt. Now, you didn't really have to do that. You could have put farads. Pico is times 10 to the negative 12. And then we're going to multiply that times the voltage source of 75 volts. And notice that the volts cancel. I'm left with coulombs. Don't be confused by the fact that we use the letter C for capacitance and the letter C for coulombs. If it's next to a number, if it's representing a quantity, a dimensional unit, capital C stands for coulombs. If it's a variable that's representing some quantity, it means coulombs. I mean, it means capacitance. Capacitance, all right? So, anyway, let's figure it out. So 15 times 75 times 10 to the negative 12. You plug that into your calculator and round it off. You get 1.13 times 10 to the negative 9 coulombs, or 1.13. What is 10 to the negative 9? That's a billionth, which is a nanocoulomb. And you don't have to do that. I just want you'll see nano sometimes. Nano means a billionth in the metric system, or times 10 to the negative 9. All right, there's our answer. So pretty simple problem, except that some people didn't know that pico meant times 10 to the negative 12, so you should know that. Remember, we have a couple of prefixes that we use a lot with electricity and magnetism, especially with capacitors. We have microfarads, which means times 10 to the negative 6 farads. Or we'll have picofarads, which is times 10 to the negative 12 farads. And sometimes you'll see nano. If you have nanofarad, that's times 10 to the negative 9 farads. Okay, and so these are your metric prefixes, because typically capacitors hold very, very, very little charge per volt. Or actually, another way of thinking about it is that a coulomb of charge is a huge amount of charge. And so we typical capacitors hold only the tiniest fraction of a coulomb, a billionth or a millionth on that order of magnitude. So anyway, that is your problem number 41. Any questions? Yes? Okay, she was just stretching. That was Ikra stretching. That is all.